All right, hi everybody, how are you? My name is Steve Guerrero. I'm the Director of Education here at the Charles River Museum of Industry and Innovation in Waltham. You're in for a good talk tonight, so I'm glad you came out. I'm glad you're supporting your local cultural institution by showing up to our educational programming. And I'd love to thank the Lowell Institute for supporting our Mill Talk series. Tonight we do have a guest that I'm especially excited about. We are a museum of industry, of building things and creating things, of fixing things and innovating technology. This is the right person to talk to us tonight. Without further ado, I would love to introduce tonight's speaker, Joe Jones. Joe is a legendary roboticist. He also was a participant in our ongoing oral history project at the museum, our Massachusetts Tech Pioneers Oral History Project. Joe and I sat for a recorded interview. The biggest takeaway I had was that I mentioned something about cool robots, and Joe told me, I'm not interested in cool robots, I'm interested in useful robots. And so, message received. And I should have known better working in a museum of industry and innovation that that's the target, solving problems. I also would love to kind of talk about Joe's ingenuity, and we're going to hear tonight that he is, I think, an educator at heart, I would say, as much as a roboticist. So Joe invented something that all of us have as a household names. Many of us have in our households, I do, and it's not every day you can introduce a speaker that has invented something that's in millions of American homes and homes around the world. I would love to introduce tonight's guest, Joe Jones. Joe.
Thank you, Steve. And I really appreciate everybody coming out on a night such as this. I hope you'll enjoy the talk. Afterwards, I have an original Roomba up here on the table, which you're all welcome to come up and take a look at. What I'll be talking tonight about is basically four stories that are kind of intertwined. And the story of robot vacuums, the story of Roomba, the story of iRobot, and sort of my role in all of this. But before I jump into the talk, would anybody hazard a guess as to the first time that robot vacuums were, there was a published prediction about robot vacuums? The year? Yeah. 62? That's a good one, but it was before that. Any earlier times? Well, okay, I'll tell you. The earliest that I could find was in 1899 in France. There was an artist who was commissioned to predict, to make a series of drawings predicting what life would be like 100 years after the year 1900, so the year 2000. And he had a bunch of fanciful, kind of dumb predictions about living under the sea and swimming with the fishes. But this was one that I really, it was amazed me that in 1899, a guy predicted that in the year 2000, there would be something like a robot vacuum cleaner. He actually only missed the prediction by 1 year. So that's really extraordinary. But once the idea got started, there was a lot of interest in it. And over the years, robot vacuum cleaners appeared in fiction. The first story that I could find was Ray Bradbury wrote a story called There Will Come Soft Rains, and in it he hypothesized a swarm of mice who would come out maybe at night and clean the floor and then go back into their hutches. I was surprised to find in 1955 that there was a TV show called Science Fiction Theater, and one of the episodes was called Time's Just a Place. And it featured what you see up there, which is the sonic broom. It was a robot that wandered around the floor, and whenever it ran across some dirt, it would disintegrate the dirt. The next year, in 1956, Robert Heinlein wrote a book called The Door into Summer. And in his book, he imagined an inventor, a guy named Daniel Boone Davis, who got rich by inventing a little robot that cleaned home floors. And Heinlein was careful to say that the robot was not especially sophisticated, but it sold well because it cost the same as a manual robot, which will turn out to be prescient. But really, the big splash that was made early on in the robot vacuum department came in 1957 when the Whirlpool Miracle Kitchen was introduced to the world. And the Whirlpool Miracle Kitchen was this vision of the future about how easy it's going to be in the future to cook and take care of your house. And there were all sorts of things. There was an electronic oven that could cook a leg of lamb in like 3 minutes or something like that. And there were a bunch of other wonders. But at the end of the program, they introduced this particular thing.
Believe it or not, the floor is automatically cleaned too, just by pressing a button. What you see coming out of the wall is a self-propelled floor cleaner. It's completely self-contained, and it can be directed to any part of the kitchen. This floor cleaner is operated by a self-charging battery. It controls itself by sensing an electrical path in the floor. As it passes over the floor, it vacuums up loose particles. And if the floor needs washing, the floor cleaner will wash it with a rotary brush scrubbing action. It will follow up washing with a thorough rinsing. And when the entire job is done, the floor cleaner returns to its location beneath the cabinet where it empties the waste and is automatically recharged to be ready for the next operation. Yes, in the RCA Whirlpool Miracle Kitchen, the things women don't like to do are done automatically.
So it turns out that back in the 1950s, only women were able to clean floors. I'm happy to report that men have made great strides in the intervening years. And that comment is actually a little bit less facetious than you might imagine, because it turned, there was a study done after Roomba came out that when a couple bought a Roomba and used it to clean their floors, the responsibility for taking care of the floors often switched from the woman to the man. It did in my house. Yeah. So there were lots of things going on in the 50s and later in regard to robots. On the left side, on this side of the screen is my favorite roboticist, a guy named W. Gray Walter. And in the late 1940s and early 50s, he built 2 robots that he called Elmer and Elsie. And it was amazing what he was able to do with what he had. He had, the robots were able to wander around. They could bump into things and not get stuck and turn away from those things. They could find their charging hutch. And Walter even claimed that they were able to learn, but I kind of dispute that claim. And it's remarkable that it was all done with analog electronics, and each robot had either 1 or 2 vacuum tubes to do the whole thing. Later on, the world turned to digital computing, and the robot that made a splash then was this one called Shaky. It was built at Stanford in 1966, and you might think that with all this machinery here, that's all you'd need to find its way around, but in fact, no. The computing was actually done off-board of the robot. There was a mainframe computer that was doing all the thinking and sending the commands back to Shaky to move around, which it did very, very slowly. A lot of people had the idea of building a robot vacuum. And one of the things that I was amazed to learn when I was doing work on my book that you will see later was the number of people who had tried and failed for how many years. So on the bottom here is a list of a bunch of patents. There were at least 24 patented attempts to build some kind of a robot vacuum cleaner before Roomba hit the stores. It started in 1957. The vacuum cleaner that you saw in the little video wasn't actually did work. The way that it was filmed, there was a guy off the side of the stage who was controlling it with a radio control, but there was an engineer at Whirlpool, a guy named Donald Moore, who actually patented this, and he had a way of making the robot drive around the floor. It was really cool. It wasn't practical at all, but he tried, and it sort of worked. And then there were all of these other ones. The probably the company that sunk the most money into it was Panasonic. They worked on a robot vacuum for 12 years. The first patent that I saw had 4 engineers as inventors, and the last one had 13. So it must have been that tens, if not hundreds of millions of dollars were poured into trying to build a robot vacuum over the course of about 46 years before Roomba made its debut. But the one thing that all of those attempts and all those had in common was none of them worked, right? They tried. It seemed like it's just around the corner, but 4 decades later, and they hadn't shown up. So there was another thing that got started in the 1950s, and this is me, and I was always interested in science and technology ever since I was a little kid. When I was 5 years old, I tried to build a satellite. It didn't work. It was a great, great disappointment when that didn't work. And at age 6, I built this supposed robot that you can see sitting next to me. So being interested in science and technology, I was trying to figure out, what can I do for a career? So about age 10, I realized that the most exotic technology sort of job that I could imagine was TV repairman. Because in those days, of course, we had vacuum tube TVs. They broke down frequently, and you had to take them into the TV repair shop. And we'd go to this shop, and the guy here there had all these TVs sitting around, taken apart, and there were oscilloscopes and dials, and it was just fascinating. I couldn't imagine anything more wonderful than that. But a couple of years later, I realized that there actually is a job that's more exotic than TV repairman, because somebody has to invent the TV, and that person must, have in some sense a better job than the TV repairman. And then I wanted to be an electrical engineer, because they invent the TVs that the TV repairman repairs. And in a couple of years after that, I realized there's one higher rung on the ladder of exotic jobs, and that is physicist, because the physicist discovers the principles that the electronic engineer uses to build the TV that the TV repairman repairs. So I came up with a plan for the rest of my career. Seemed simple enough, 6 simple steps. I was going to graduate from high school. I was going to go to college, get a PhD. Then I would get a job in experimental physics at some physics research organization. I would invent faster than light drive. And on the strength of that, I figured I could get a ride on the first spaceship going to Alpha Centauri. Oh, and that's my high school over there on the left. So the first part of my plan went okay. I did graduate graduate high school, and I'm happy to report I was first in my class, which is a little less impressive when you understand that there were only 38 students in my high school graduating class. And I went to college, but then when I got to graduate school, I ran into a snag. Because although I thought physics was really cool, and I was really passionate about physics, there was no particular branch of physics that I was passionate about. And when you graduate school, you have to specialize, right? It's plasma physics, or condensed matter physics, or optics, or something. And there was just nothing that I was passionate about. So I decided I will fix my plan. I will patch it. I will get out of graduate school. I'll go to work at some physics research institution on the staff, and I'll figure out what my physics passion is there, and then I'll go back, get the PhD, and off to Alpha Centauri. Well, it turns out there was a second glitch in my career plan, and that was I worked at, it was a linear accelerator, the one in Bates Linear Accelerator in Middleton, Massachusetts, that I worked at. And for 3 years, I still didn't find my passion in physics. So I figured it wasn't working. I was in a rut. I had to do something different. So I decided I would take a trip around the world. And then after that, I wasn't quite sure what the career plan would be. But I did that. I started off in Boston, and I traveled west around the world, visited a whole bunch of really, really cool places. I spent a year doing it. Did not discover my passion anywhere out in the world. And then I got back to, I was living in Somerville at the time. I was out of money, and whether it fit into the career plan or not, I just needed a job because I was borrowing money from my friends. So I had to do something. And then I got very, very lucky. I got a job on the research staff at the MIT Artificial Intelligence Lab, which is now called CSAIL. And when I got there, within a few months, I realized this is the place for me. I mean, look at all this wonderful stuff here. There's all kinds of robots. There's this thing called the connection machine, which is an early parallel computer. The robot that I actually was supposed to be working on was this arm up here. There was all these brilliant people with really cool ideas and great equipment. And I thought, this is the place for me. I will stay at the lab forever. Also at the lab at that time was this fellow. This is Professor Rodney Brooks. And there's an interesting connection back to the W. Gray Walter. Brooks was kind of dissatisfied with the way that robots were going. Nothing had been much better than Shaky, the digital computer robot with the off-board brains that moved around very slowly. So Rod Brooks came up with this new paradigm for robot control, which was called behavior-based programming or behavior-based robotics. And he basically turned the conventional wisdom on its side. And by doing that, he was able to build robots that were very, very responsive, that reacted really quickly. And it seemed to me like this is the way. This is the way robots ought to be done. And the interesting connection is that W. Gray Walter had written, he was a neurophysiologist. He was interested in studying the brain, and he built robots in order to study human brains. And the wonderful book that he wrote, Rod had a copy of when he was a kid. And he liked the ideas, he liked the results of the way that W. Gray Walter was designing his robot brains, and Rod kind of formalized it. So while I was working at the AI lab, there was this event in 1989 that was put on by the mobile robot group that Rod was the leader of the mobile robot group. And what they decided to do was to hand out kits of parts with Lego and sensors and microprocessors, and they prepared documentation and tutorials to teach people how to use this stuff. And the idea was that anybody who wanted, anybody at the lab, anybody associated with the lab, could spend the month of January 1989 building whatever kind of robot they wanted. And then at the end of that month, there would be a robot talent show in the faculty club. So here we are, opening parts and learning about robots. And then a really cool thing happened around the time of the talent show. Channel 2 came to the lab, and they filmed it.
Welcome to the Artificial Intelligence Lab at MIT, the cutting edge of computer research. Some of these robots even fly.
It's an autonomous blimp. It will sort of fly around the room. Using sonar, we're able to determine what is around the blimp, people, walls, basically things we don't want to hit.
But with a little work, they eventually go right, as these students demonstrated at a robot talent show last week.
So when the robot talent show came along, I thought it was a golden opportunity to build a little robot that I could then take home and have it run around all day long, just cleaning my apartment. It runs around in an increasing spiral, trying to pick up all the dirt, which it sort of does.
So that I claim to be the earliest direct ancestor of Roomba, and I'm a little bit optimistic there. It's not really picking up the dirt very well, but having built the thing, I was confused. It didn't seem like it was that hard to build a robot that could clean the floor, so why couldn't I go to the store to buy one? Turned out there were a lot of things in the way. From the time that I decided that I would build a robot for the robot talent show to actually building it and demonstrating it in front of everybody took about 1 month. From then until we actually launched Roomba, 13 years. So, so another thing messed up my career plan. Not long after the robot talent show, it turned out the lab ran out of money and they laid off all the research staff. So I was let go then. But fortunately, in those days, there were hardly any robot companies in the United States. But there did happen to be another one close by in Wilmington, I think it was. And it was called Denny Mobile Robotics. And I knew a guy who worked there I told him I needed a job. He got me an interview with the folks at Denning, and they hired me. So Denning built big robots, big, expensive robots. This is the Denning Sentry. That was the sort of the flagship of the fleet. And it was supposed to patrol office buildings and warehouses after hours, and it cost $75,000. In 1989, it cost $75,000. It didn't get a lot of customers, so I thought, I have just learned this great new way to build robots using the behavior-based paradigm. What I will do is demonstrate this to the folks at Denning, and I'm sure that after they have seen that little robots can do really cool things at a really low price, really useful things, I should say, they'll switch the whole business plan and we'll do this. So I hooked up with this guy called Jack Shimmick, who's a mechanical engineer, and we got permission to spend a few months as a back burner project trying to build a little robot that would clean home floors, which we did. So a day came and we demonstrated the robot. We set it up, we demonstrated the robot to the entire company, including the president of Denning, and Jack and I thought, you know, anybody with half a brain can see how much potential this thing has. This is going to be big. And then Jack and I were fired. Now, it turned out that we did not convince the president of Denning that little robots were a thing. He liked big robots. And, well, he didn't actually say that we were fired. He said we were on furlough, but we're still waiting to be called back. Very fortunately, another robot company was forming around that time. So Rod Brooks and his students, Helen Grainer and Colin Engel and his wife Jill, had just started a company which they called IS Robotics. And their idea was to commercialize Rod's paradigm, new paradigm in robot control. And I applied for a job there, and when they got funding, they hired me. So I was the first full-time hire after these folks. So I told my new colleagues all about the sad story of Denning. And Colin had been there for the robot talent contest. He was a student at the AI lab at the time. And everybody, my new colleagues, were excited about the idea of building a little robot that could clean home floors. The problem was, it takes money to develop something like that. We didn't have any. All that we could do was, try to make payroll every month by doing research contracts and delivering demonstration robots to people who would order them. There was no extra money to develop something like a robot floor cleaner, so that didn't happen. But Colin suggested, well, maybe somebody will partner with us. And the obvious partner was, turned out to be Bissell, because Bissell had made the cleaning mechanism, the carpet sweeper mechanism that Jack Shimmick and I had used in our RoboBroom. And there had been another group at the AI Olympics that had also built a floor cleaning robot, and they, I think, had used a Bissell. So anyway, I made a carefully worded letter and sent it off to Bissell, and they were not impressed. What they said was that nobody will pay more than $20 or $30 for a carpet sweeper. The robot will cost more than $20 or $30, therefore we're not interested. Straightforward proposition. So we put the idea of a little robot vacuum on the back burner, and time passed. And during that time, we built all kinds of cool robots at iRobot. This is a hazardous materials robot. This is a research robot. This is a robot that is supposed to pick up unexploded munitions from a battlefield. A lot of cool projects that were really fun, but we didn't have any money. And the thing you can see in the background, we didn't have enough money to pay people to clean our offices. So we all had our own cleaning duties. And you'll see that I had a great incentive to build a robot vacuum cleaner because I was supposed to do the vacuuming. So things improved over time. The slide might not suggest it, but things did improve over time. Over the course of 7 or 8 years, the company gradually became more financially solvent until S.E. Johnson came to iRobot and they wanted them to build a robotic auto scrubber. Now, you might not be familiar with the term, but you have definitely seen an auto scrubber. It's this device that you'd see late at night going down in a hospital or in an office building or something, and it cleans and burnishes the floor. So S.C. Johnson had this idea for a business plan involving a robotic auto scrubber. So we started a project. The project turned out to be a really big project. It was probably the largest team that iRobot had ever put together. Really fascinating stuff. I loved working on it, but it was a train wreck. Everybody was at each other's throats. It was hard to make progress. People were constantly arguing with each other, and it didn't work out at all well. So eventually, S.C. Johnson pulled the plug. And then a colleague of mine, whom I'll introduce in just a moment, sent me a message, and he said he'd been thinking and had kind of decided one of the problems with the auto scrubber that we had tried to build was it's big and it's uses a huge amount of technology and it's costly. What if we go all the way the other direction and build a little robot that cleans home floors? And sometimes I have the email that was actually sent, but it was my colleagues. Please stand up and say hello. This is Paul Sandin. This is the guy who sent that message that started the whole Roomba project, or started it again anyway. So we proposed to management that we build a little robot that cleans home floors. And a vice president of the company who had come in and run the tail end of the clean project and took over from a different manager and made it less bad than it might have been. He was the one that we presented our plan to, and he accepted it. And what he said was, okay, you two guys can work full-time for 2 weeks, and you can have a budget of $10,000, and at the end of that time, you have to demonstrate your little floor cleaning robot to the company, and then we'll see what happens. So we did that, and we worked very, very diligently for 2 weeks, and at the end of the time, we had scamp here. And then we demonstrated it to the company, and instead of getting fired, they decided they would actually do it. So we assembled this team of, this is the core Roomba team, and we worked for the next 3 years trying to build this robot. It was a great time. We were all shoehorned into this small office where 6 of us were sitting in the office. Our project manager, Winston Tao, the guy who was in the first picture there, he got a little bit more prestigious office. He was a vice president after all. But the rest of us were shoehorned into this office. And this is some of the stuff we always had a table in the middle where we worked on robots. This is my office. This is my muse hanging above my desk here. We had to have a little floor, a piece of floor where we tested all kinds of different flooring materials. There was carpet and tile and whatnot. And the thing that made it good, being in such a cramped space, was that you couldn't not know what everybody else was doing, because you could overhear their plans. And it happened at least a couple of times that I was aware of, where somebody was saying, I'm going to do something somewhat this way, and someone else would pipe up and say, but you can't do it that way because it'll cause this other problem. So that was really useful to have that. So we were working along, and at some point, our project manager, Winston, said, we need to have a focus group. We need to know what people actually think of this thing that you're building before it's actually launched. So this is not a photograph of our actual group, but it looked exactly like this. There was a table, and there were snacks on the table, and there were engineers around the table, and we're looking through this one-way mirror, and on the other side of the mirror are bona fide ordinary people, regular people, and then there's a facilitator who's leading them through the exercise. So we had a prototype that we had delivered to the focus group, and the facilitator talked about it, told them what it was. She did not tell them how it worked, but they saw it, cleaning the floor and working properly. Before she told them how it worked, she asked them what would they expect to pay for a robot like that. And the answers were all over the map. Most people said, unrealistically low numbers. A few people said $200, which is what we were trying to charge. And a couple of wonderful people said like $1,000. So we loved them. But then she said, the robot is not a vacuum like you have been saying that it is. It's a carpet sweeper. It doesn't have a vacuum in it. And then she asked again, how much would you pay? And the people cut their estimate in half. So it turned out that if we had to charge that, if we had to cut our price in half, then there would be no Roomba. We couldn't do it at that price. So we left the focus group and we realized that we have to add a vacuum to Roomba. We hadn't been planning to add one at all. It turned out that the energy budget only had enough energy for a carpet sweeper mechanism. That was the whole technology that made the thing work, that you didn't need this power-hungry vacuum to clean your floor, and now we have to add a vacuum at the last minute. Well, the idea that at least one of us proposed was that we'll just add a vacuum that doesn't do anything, and on the box we can say it has a vacuum, because it will have a vacuum. It just doesn't do anything, because it already cleaned well enough. But nobody liked that idea. So the robot was designed to consume 30 watts of power. And through our discussions, we decided that if we could build a vacuum that only took 3 watts of power and did something useful, then we'd all feel good about it. But it didn't seem possible, because normal vacuums, the biggest vacuums that you can buy for your house take like 1,400 watts. We had 3 watts. But I did figure out a way to do it by playing around with staring at some vacuums and playing around with them. It turns out that what you need to do to make the vacuum actually do something is have a high velocity of air. So regular vacuums have a big brush, they have this huge air inlet around the brush, they suck in huge gulps of air, and it works well. It keeps the dirt entrained in the airstream while it's running, and it takes it to the disposal bag. But if we wanted to have the same velocity to keep the dirt suspended in the air, what we had to do was to build a really, really narrow inlet. So that's what we did. So we had this inlet that's only like 1 or 2 millimeters wide, but it actually worked. The thing that's uncommon is that generally regular vacuums work best on carpets. The vacuum that we added to Roomba didn't do anything when it was running on a carpet, but it enhanced the performance when it was running on a hard floor. And we could tell this by putting grit on the hard floor, having the robot go over it without the vacuum turned on, and walking on it barefoot, and then you turn the vacuum on, let it run again, you walk on it barefoot, and there's no grit. So we were very pleased with that. Now, during this time, I told you that lots and lots of people were trying to build a robot vacuum. One of the companies that tried to do that was Electrolux. And the leader, the guy who did the project, was this dapper gentleman in the middle here named Per Ljunggren. And long about 2001, when we were sort of 2/3 of the way through Roomba, Electrolux made a big announcement. They announced that they are now selling a robot vacuum. And here is the way that they presented it to the world.
All the way from Sweden, it's billed as the world's first fully automatic robot vacuum cleaner. And the vacuum cleaner crisscrosses the floor at random. Eventually, it should cover the whole room. The radar eyes are always on the lookout for any obstacles. So, the vacuum cleaner shouldn't break or suck up anything it's not supposed to, including any moving objects.
So, this surprised us. And the reason that it surprised us was because this presentation, which occurred on BBC television, was in 1996. This was in 2001 that Electrolux finally announced that they were selling these things. We had heard no news since that program So we thought, well, they've gone the way that all the other vacuum cleaners have gone. They've totally failed. But in fact, they had been working diligently, and they actually delivered their vacuum, and we were very upset. We didn't know what was going to happen. But we finally managed to get one and to get some more information about the robot, which they call Trilobite. And what we found was that they were going to charge $1,500 and that their robot was 5 inches tall. Well, Roomba was going to be about $200 and it was going to be about 3 inches tall. So we figured that that's too much. It costs too much. No, people won't buy it at that price. And also at 5 inches, there's a lot of furniture and kitchen toe kicks that it won't get under. And we thought the robot really needs to get under those things and clean there. So we were somewhat calmed when we discovered the details of the Trilobite. Now, it turned out there is this event called commit to tooling, and when you are making a product, there's a point where you have to commit to the tooling, and what that means is that you tell the factory, okay, we have sent you the files, these are the final files that our product is going to use. Go ahead and take huge chunks of steel and cut the patterns into them that are going to make the molds for the product. So you can make any changes you want before you commit to tooling, but after you've done that, the changes get really expensive because you have to throw away these big things and do them over again. So about 2 weeks before we had to commit to the tooling, Winston, our project manager, came in to us and said, let's do a little test of Roomba. And the test was, we were going to put a little dirt, a really simple test. We're going to put a little dirt on the floor, we're going to aim the robot at the dirt, have it drive over the dirt. We did that, and the dirt was still there. It didn't pick the dirt up. Now, it's not like we had never tested it before. We had tested it extensively. There was all kinds of testing that we had done. And we could demonstrate that it really did work, right? So what was happening? Well, we didn't know what was happening, so we panicked and tried every way we could think of to figure out what was going on. Finally, fortunately, in not too awful long, we did, and this commercial that iRobot put out a couple of years ago actually demonstrates what was going wrong if you know what to look for. Now, did you see it? I'll slow it down again, and you can see what's happened. When you look up under the robot, so here's the brush spinning, this is the back of the robot, any dirt that comes back down here is going to be missed. And there was a piece that fell down, but it had enough velocity going forward that the dirt got back under the brush, so it got a second chance to pick it up. So what was happening was there is a shroud that wraps around the brush, and somehow, inadvertently, we had made that shroud wrap a little bit less around the brush, and that made Roomba not clean. So when we figured that out, then we were able to fix it in really pretty short order. So that was a fortunate thing. Now, the focus group and the Roomba picking up the dirt test that we did was something that our project manager, Winston Tao, had asked us to do. And it turned out that wasn't just a random choice that he had made. He had done this very deliberately because, unlike the rest of the engineers, he didn't believe that people would buy a floor cleaning robot that didn't have a vacuum. And he also knew from talking with the people who were trying to make the marketing videos that when Roomba didn't clean, he knew that it didn't clean. But he couldn't just say that to us. He had to find some clever way of showing us so that we internalize the fact that these are problems that we have to solve. So that was one of the wonderful things that made Roomba work, because he did that. So it all kind of worked out. September 2002, the product was launched, and there's a curious thing about this box that it came in. And if you look at the box, It doesn't say anywhere that this is a robot. Instead, it says it's an intelligent floor vac. And that was deliberate because we were kind of afraid that people wouldn't want a robot in their homes. Maybe they'll think it's like Terminator or something and they'll be afraid of it. So we deliberately didn't say that it was a robot, but it turned out people actually liked the fact that it was a robot. So after the first box, it said that it's a robot on all subsequent boxes. Our initial sales were a lot more than what anybody expected. And so for the second year, we thought the same thing would happen again. So the company stocked up. But then late in the year, they realized that we've got an awful lot of robots sitting around in warehouses and not being bought. So it was a real dilemma, and I did not hear about this at the time, but supposedly management was thinking about discontinuing Roomba, believing that it had failed. And then this commercial happened.
I'll be ready to go in a minute.
Take your time. A vacuum. You like that, don't you? All right. Thirsty now, ain't you? Little Pepsi. Oh, man. Your vacuum cleaner ate my pants. There's nothing I could do.
Nothing chases chips like a Pepsi. It's the cola.
Now, if you can understand how that commercial sells Pepsis, you're brighter than I am. And I certainly can't imagine how it sells robot vacuum cleaners that don't even appear in which don't actually even appear in the commercial. But it did. And after that commercial aired, Roomba sales took off, and there was no more talk about discontinuing the product. So I used to watch Saturday Night Live all the time, and I was watching it one evening when this sketch came on. I watched this stunned. This little robot that I had worked on for so many years was being parodied on national television, and I realized that it has become a sort of a cultural icon. It was a really cool moment. It was cool for iRobot as well. After 15 years as a startup, they finally were able to do an IPO in 1995, or 2005, and sort of become a real company. So, do we have a fairy tale ending? Yeah, sort of. What we all talked about in the early days at iRobot was that we wanted the company to be the robot company. What that meant, at least to me, was that as soon as we could, we were going to try to build all kinds of robots for all kinds of different applications. Anything was fair game. And as soon as we had a reliable income stream and the existence of the company wasn't threatened at the end of every month, then we could start to do that. That was not what management was thinking. What management was thinking was, we've got a success, now we can stop taking these crazy existential risks. We can just build products that we know customers are going to want. We can exploit what we've got. And that makes me think that the situation is something like this. When you're a startup, it's sort of like the old prospector who scours desolate lands looking for treasure. And what's most likely going to happen to this guy? He's going to get bit by a rattlesnake, or he's going to run out of water and die in the desert, or his mule is going to kick him in the head. But it's going to turn out badly, right? But in the very unlikely event that he actually finds gold, then you open a gold mine. And then everything changes. Because before, it was just, instincts and innovation that are driving the people working in the startup. As soon as you've got a product that you can exploit, there's all kinds of business books that tell you how to do that, and the rules that you follow to make the most money that you can. So that pretty much is what happened, and why, after a while, all of the Roomba team members had left the company. But this actually does work well. It does make a lot of money until the vein plays out. And if you get to the place where you can't exploit the thing that you built anymore, and you haven't discovered the next thing, then you're kind of in the situation that iRobot has found itself in recently. So what I've been doing since leaving iRobot, I founded a couple of companies. One of them, Harvest Automation, makes robots that moved potted plants around nursery farms. Another one called Turtle, we built a little robot that weeds home gardens. And I've also been writing books, the one about Roomba. Now, compared to my original plan, it didn't really turn out that way, right? I didn't get a PhD. I didn't discover my passion in physics or invent faster than light drive. I didn't stay at the lab or iRobot forever, but I did get to found some startups and invent a bunch of robots that were great fun and write a book. So, do you have any questions?
Thanks, Joe. Raise your hand if you have a question. Please wait till I get to you with the mic so we can record the question as well as Joe's answer. Thank you.
Field testing and testing during development is one thing, but when you have thousands and millions going out in the world, there must be some things that happen that you didn't anticipate. Could you tell us about that? I heard something about pets, for example.
Yes. Well, there were many things that happened when the robots went out into the world. Some of them deliberate, and some of them not. One of the things that surprised us the most was the cat videos. Why would people put little animals on their robots and film them running around? We thought it's a tool, right? It cleans your floor. So that surprised us. Another thing that surprised us was sort of the worst thing that surprised me is some guys made their Roomba play Frogger by directing it across a busy highway. That didn't seem like a very prudent thing to do. Other things that we kind of knew would happen did happen, and one was if you have your Roomba, especially on a schedule, and you've left it at home with the dog, and the dog has an accident, and then Roomba comes out and tries to clean up the accident. Of course, it doesn't actually clean it up. It just smears it all over the floor. There was one thing that we were worried might happen that never happened. Fortunately, we thought that in a house, if you have a fireplace, usually the floor's on one level and the fireplace is raised relative to it. But some houses aren't like that, right? Some of the fireplace is flush with the floor. So if you had a cozy fire going in the fireplace and you weren't watching and Roomba went out to clean your room, it could drive right into the fire, pick up some embers, and then drive and spread them around the room. We actually worried quite a bit about that. But instead of trying to build an extra sensor or something which would have been very complicated and expensive, we fixed it with ink. We wrote in the owner's manual, you must not use this near fire or flame, right? So, but it's, as far as I know, that has never happened, I'm happy to say.
Thank you for the talk, fascinating.
Sure.
So were you the visionary behind iRobot Create platform? I'm using that as building a telepresence robot. So or if you can share any stories, if you.
So iRobot's which platform?
iRobot Create, the Roomba that you can
Create?
program, yeah.
That was a way of sort of trying to give back to the community. I wasn't actually involved in that project, but since we had Roomba already. Maybe Paul?
I don't think any of us were involved in that. It just appeared by itself. Some other part of the company decided to turn it into a robot that you could use it for. So we took the whole guts out and it just like a little basket in the back.
Yeah.
And it was very popular. Yeah, sorry. It was some other member of the company that came up with this idea of turning robot into a robot that you could use not for cleaning. So they ripped out the back and made like a little basket and changed the code a little bit. I think you can reprogram it and stuff.
Yeah.
But it's exactly what the questioner asked. That's what they were intended to use it for. And it was popular for quite a while. We did pretty well.
Yep.
I really enjoyed the journey that you had. So I'm also coming from, I work with different robotic companies, and based on what you were telling, like the big things, big jumps you made in like very short amount of time, like in 2 weeks. So now that like we have sort of like better computers, AI is like better, the improvements that I can see that's happening is just, to me, is like actually slower. Like in 2 weeks, how big steps I can tell that companies are making. So you personally think, what has changed? Is it like about people's personality, like people in the past were like putting more efforts to just see things change? That's like different now? Because to me, based on your experience, like in 2 weeks, having that prototype that you were showing was like incredible.
So the biggest thing that has changed is artificial intelligence. The way that artificial intelligence, at least this is my opinion, the way that it's done now is, well, it's a new technique. It's artificial neural nets, and all of the recent advances have been basically based on that. So it's a technique that had been known for a long time, and it was known when I was at the AI lab, but it didn't work very well then. And most of us at the AI lab thought, this will never amount to anything. And now it's sort of eaten the lunch of everything else. Again, my own opinion is that it's kind of perplexing in a way, because in one way, it's really useful. In another way, it is fundamentally unreliable. So you can get into trouble if you rely on something like that, because most often it's useful. Other times it falls on its face, and you never can tell when that's going to happen.
Talk about the team and how efficient we were. That's part of how we made changes so rapidly, was how well we functioned as a team, which I also think is rare nowadays.
The team was, the Roomba team was the best team that I had ever worked on. And the thing that made the team work as well as it did, I believe, and I think most of us believe, was that we were internally motivated. The thing that we wanted to do was not, build a company and make a lot of money and get promoted. We wanted to build the first robot that cleaned home floors. And everybody was totally focused on doing exactly that. So and we had no egos. So that made everything smoother.
Great talk. I'm wondering, I have two questions. First one is, how many Roombas do you actually have at your house? And the next question is, do you have a favorite model?
I have one Roomba that works, and I have one Scuba that still works. That's the floor mopping robot. Now, what was the second one?
What's the favorite one?
Oh, the favorite? Oh, you can't pick favorites among. Well, my favorite one is the one that I helped to build. This one, because this is the one where we went from 0 to 1. All of the other ones they virtually use all the same sort of technology, and they made it better, they improved it. But the hard part, the fun part, is going from something that doesn't exist and solving all the problems that have to be solved, and there are all kinds of problems, not just technical ones. And getting that to work, that has to be the best.
Are there any vestiges of the analog computing that Professor Brooks was promoting, or is it all digital?
Wait, say that again?
This is based on the time of Professor Brooks, who was advocating analog.
Oh, he wasn't advocating analog. He was advocating a certain approach to robots. The approach that people were taking at the time that he wrote his paper was called planning. Basically, where you figure out where everything in the world is. You sit and think for a while. If you have a task, typically to get from some place to another place, or if you're a manipulator robot, to carry a thing from one place to another place, and you sit and think for about it, And in those days, it didn't work very well. It took, I mean, it did work, and you could prove that it worked. And that was the advantage, but it was slow and it was brittle. If anything changed in the environment after you had made your plan and before you executed it, your plan would fail. So the big advantage was building this system that relies on a bunch of sort of elementary behaviors that all work together most of them without really knowing about each other. But when you put them all together, you get this emergent behavior that does the thing that you want. And that was how we built Roomba and basically every other robot that I have built.
Hi. It seems like robotics today is focused on humanoid forms, and a humanoid that can pick up a non-robotic vacuum or a mop or load a dishwasher or something like that. What do you think that's the right direction versus the function specific? Or do you think that will be a flash in the pan for a return to function specific, in a few years?
Well, the thing that people, it's not exactly a new idea. The idea of making a general purpose robot that, you buy this one thing and it can do everything. And in the early years of robotic, at least, well, from my point of view, the early years when I was starting off in my career, people who tried to do that, nobody made any money at it. You tried to build this general purpose thing, and it was always way, way harder to build a thing that can do everything rather than a thing that can do one thing. And it was also a lot more economical to build a robot that could do just one thing. So that was what I focused on. So now, because of AI, because it is so powerful, people have started again to think that we can build a general purpose robot, and what better form of the robot than one that looks like us. That's not where I would put my money if I were investing in robots. I think that it's still a really tough problem. One of the things that you don't get is one of the things that humanoid robots are not good at is things that require tactile manipulation. And the way that AI thinks is using language, right? But language is not the same thing as thinking. So we are able to reach into a pocket and feel around and pick the coin we want, just based on the way that it feels. And the training is a key part of building a humanoid robot, right? You have to show the robot how to do something, and after it's seen it a bunch of times, it generalizes from it. But what the robot doesn't have are the kind of tactile sensors that we have. We have several different kinds. It's not just pressure. There's several different kinds of sensors that we have in our fingers, and we have them because we need them to do tactile tasks. So robots aren't going to do that for a while because there's not enough research going on there. Maybe that's a long-winded answer, but I can't deny the argument that if you had a humanoid robot that was a general purpose robot, it could do anything, and it didn't cost very much, it might make economic sense. I don't think we're there, and I don't think we're going to be there within the next 10 years.
So looks like Roomba or robotic vacuum or mops are the only popular home robots right now. Were you surprised at this scarcity of the variety of home robots? Were there some kind of home robot you thought would be on the market by now, but still not?
It's okay. So when we were developing Roomba, we all believed that robot floor cleaning was sort of the lowest hanging fruit on the tree of robot possibilities, and the next higher fruit was way up there. And that is kind of why we've stuck at only having robot vacuums, because most of the other tasks that you want to do are much, much harder. It's the technology that you use to clean the floor, for example, doesn't help you at all if you want to clean the toilet or the bathtub or the windows, right? You have to do something completely different. And I think that will change, and I have I'm always able to come up with ideas about how it might be done. But you're right. Basically, the only really popular home robot is ones that clean the floor.
It was a really great talk. So interesting. I have a question going back to when you were a little kid and wanted to be a television repairman. How are these fixed? I mean, I don't actually own one, but it's a machine. Machines break.
Yep.
What do you do with it when it breaks? Who services them?
Well, we did set up servicing very early in the life of Roomba. They would come back. I was surprised, actually. I thought generally if it broke, we'd throw it away and get a new one. But it turned out that it did make economic sense, at least at that time. I don't know about now, but at that time, they developed this whole procedure for taking robots back, and they weren't fixed at iRobot. It was some other group that did it, but they managed to do it economically.
Where do robo scientists go for inspiration? What were your main sources of inspiration, and also what are some of the coolest pursuits that you've seen in the recent years?
My sources of inspiration? Oh, I just like technology, right? It seemed like it ought to be doable. I guess I can't pin it down to one particular thing. I was always trying to be opportunistic, right? It wasn't that I approached robotics saying I have to build this robot floor cleaner. I just wanted to build something that worked, and it looked like that was the simplest thing that I could build that would work. And then you asked.
What are some of the coolest pursuits that you've seen in the recent years?
Like the coolest robots that I've seen? I recently saw a robot that I thought was very interesting. One of the things that people complained about with Roomba was, well, what if you have stairs in your house? You'd like for it to clean the stairs. And it seemed really complicated to make a robot that would clean the stairs. But I've seen somebody has done that recently. It's a very clever thing, which has these arms that go up and then pulls the rest of the robot up. And it's even able to go back and forth across the stairs, which is the cool trick, and clean the stairs, sort of. I don't know that it would work on all stairs. The arms may have to be a particular length, but I was surprised and amazed to see that.
I want to thank Joe for spending time with us tonight. Thank you, Joe.
Thank you.
And thank you for coming out, and I can't recommend highly enough Joe's book, Dancing with Roomba, if you are interested in getting a more complete story than we shared tonight. Thank you very much, everybody. Thanks for coming out.
Thank you. So, the robot engineers at Saturday Night Live are clearly much more talented than we were. We couldn't make something that small that can climb walls and such like. But anyway,